Welcome. This is chapter 3, Everyday Force and Energy, grade kindergarten, subject science. The chapter dates are September 25th through November 10th. Therefore, ending in the first 9 weeks, going to the second 9 weeks. An overview of the chapter is magnets push and pull, lights help us see. Shadows form when light is blocked. In this chapter, we are going to be learning about everyday force and energy. The students will explore how magnets can push and pull, how light helps us see objects, and how shadows form when light is blocked. Our big question is, how would a magnetic light be useful? By the end of this chapter, we'll be able to explain magnets, light, and shadows through hands-on investigations. In the chapter overview, we describe and predict how magnets interact with materials, how objects are visible only with a light source, shadows, and how shadows are created when objects block light. The essential question, as I already discussed and pointed out, big ideas. And a lesson breakdown. Of course, we've seen lesson 1 in the first 9 weeks, but I'll go ahead and talk through it really quick, just so we can have a summary, because of course, each of the lessons build on the last one. So it'll be a good idea just to kind of review it really quick. Each lesson in this chapter, duration is 8 days. In lesson 1, we saw magnets push or pull. The vocabulary terms magnet, push, pull, material, and object. Some of the activities were to observe and investigate magnets, the hands-on pick it up investigation, your CER graphic organizer, and the virtual field trip. Magnets all around us. Jumping towards the lesson 2. Remember that our CR is going to be a graphic organizer that the students are going to have to see in order to build on their communication skills and observation skills. Moving forward to lesson 2, lights and objects. These are the TEKS. Vocabulary terms: light, light source, bright, dim, material, and object. For the activities, there is the hands-on investigation, observe light with various objects, compare bright versus dim light effects, claim evidence, reasoning graphic organizer, the CER, and watch Meet a Physicist video. In lesson 2, a discussion prompt may be, how does light affect the appearance of an object? And for your CR checkpoint, the claim may be, objects can only be seen when a light source is present. The evidence could be, we cannot see the toy until the flashlight was on. And the reasoning could be, because light is needed for our eyes to see objects. So we just want to make sure that the students are able to make a claim and then stand by it with a reasoning as they're exploring. We're going to lesson 3, shadows. TEKS are as followed. The vocabulary terms are light, material, object, block, opaque, shadow, transparent. Activities for this lesson include to investigate how light passes through transparent versus opaque objects, create shadows with objects with your hands or objects, of course your CR graphic organizer, and observing shadows, shadow changes through the outdoors. Of course, the discussion prompt for this lesson, how do objects change how light travels? And an extension option that is included in your chapter guide is to create a shadow puppet for shadow play. Alrighty, this is pretty much it. A few common misconceptions are, of course, not all metals are magnetic. Light is always needed to see objects. Transparent objects allow light through, and opaque objects block it. And shadows form only when light is blocked. Okay. These are some STEAM and extension options. Pages for your TE are included. As such, they are also listed in your Chapter 3 kindergarten chapter guides, Math Connections and Technology Integration. And some teacher tips and instructional notes are, of course, to use at least 80% of this class time allocated to science for hands-on investigations. A quick chapter wrap up, you want to make sure at the end of the chapter that they all know magnets can push or pull some objects. We do need light to see objects clearly, and shadows form when objects block light. Of course, revisiting your big question, how would a magnetic light be useful? And can you explain your idea using your C or graphic organizer? Thank you.